How do polynomial degrees apply to real-life modeling? Imagine trying to predict how a roller coaster moves or how a car accelerates. These are real-world examples where polynomial functions help us understand what's happening. Polynomials are algebraic expressions made up of terms with variables raised to whole number powers, like x squared or x cubed. The degree of a polynomial is the highest power of the variable in the expression. For example, if the highest power of x is 3, then the polynomial is called cubic. If it's 2, it's quadratic, and if it's 1, it's linear. The degree of a polynomial tells us a lot about how the graph of the function will look and how it behaves. For a linear polynomial, the graph is a straight line, which shows a constant rate of change. Quadratic polynomials create parabolas, which can open up or down, showing acceleration or deceleration. Cubic and higher degree polynomials can have more complex shapes with multiple curves and turning points. In real-life modeling, the degree helps us decide what kind of polynomial to use. For example, engineers might use cubic or higher degree polynomials to model how a bridge bends under weight. This helps ensure the structure is safe and can handle different loads. In aerodynamics, polynomials help simulate how wings generate lift at different speeds, guiding better airplane designs. Economists use polynomial models to analyze trends like stock prices or population growth. These trends often don't follow a straight line, so higher degree polynomials can fit the data better and show more accurate patterns. In data analysis, fitting a polynomial curve to data points helps visualize complex trends in markets, health data, or environmental changes. The number of solutions a polynomial can have is also related to its degree. A quadratic can have up to 2 solutions, which might representing different possible outcomes in a real situation. Higher degree polynomials can have even more solutions, helping us understand multiple scenarios or turning points. Knowing the degree of a polynomial makes it easier to simplify expressions, solve equations, and graph functions accurately. This is important when creating models that reflected real-world systems. So, understanding polynomial degrees is key to building useful models. It helps us predict how systems behave, whether in engineering, science, or economics. By choosing the right degree, we can make our models more precise and better suited to the real-world problems we want to solve.